Thanks for coming to the last session of the day. Sorry, the last session has to be in English, but it might be better than the Japanese, that my native language. So hopefully you'll be able to understand me in English better than the Japanese. So my name is Hayato Shimizu. I work for a company called DataStax as a lead solutions architect. And we specialize in Apache Cassandra, and that's what I'm going to be talking to you today. So, just going to show you a picture, okay? So, a modern day living. Yeah. So, this is a lounge or living room, okay? It's not my wife's kind of living room. She would absolutely hate it. She's English and she likes old houses with low ceiling and the wooden beams and the ones you bump your head onto. That's the sort of properties that she likes. But a typical modern day living room may look like this. I just downloaded it off the internet. Okay. Well, why am I showing you this? It's because we live in a connected world. Okay, everything's connected. Climate control. Who's heard of Nest? Yeah, thermostat. Yeah, great. It's a thermostat. Google bought this company for $3 billion recently. It's a connected thermostat that monitors and controls your house for you. Lighting controls. Video calling. Who's got Skype on their television these days? Internet television, watching television online, yeah? Streaming music, Spotify. Yeah, do you get Spotify in Poland? Yeah, great. Gaming, online gaming. Banking. Yeah, you're going to be making payments and controlling your accounts. E-commerce, who likes shopping on their iPad? Yeah, everything's connected in your living room these days. Okay, so a lot of these services that you use on the internet, they are using Apache Cassandra already. Okay, so that's what I'm here to talk about today. So all of these devices, they're collecting data from you all the time. Okay, let's just say each living room may be generating a megabyte of data a day. Across, say, sorry, I got that slide wrong, 10 million homes, you're generating 10 terabytes of data a day. Sorry, 50 million homes, you're going to be generating 50 terabytes a day, and you're going to be generating over 3 petabytes a year. Okay? That's a lot of data that you're going to be handling. Yeah, with this kind of services that you're going to be putting out on the internet. So, Apache Cassandra. Who's heard of Apache Cassandra, by the way? Yeah, very few. Who's using it in production already? Wow, great. So, Apache Cassandra is a database. Yeah, not just an ordinary database. It was created at Facebook. Yeah? When you talk about big data, Facebook, I've got a big data problem. They've got a lot of data. So they created Apache Cassandra to solve their inbox problem initially. Yeah? Again, a lot of data to store, a lot of data to search. And a guy called Avinash and Prashant created it by marrying two technologies together. So Google Bigtable as the storage engine mechanism, and Amazon Dynamo, so that's their key value storage that Amazon developed to solve their particular problem around shopping basket and so on. Yeah, and so they married the two papers published by these companies into a single solution called Apache Cassandra. Okay? So just to set the record straight, so Cassandra is a highly distributed database, okay? It's a distributed database. It's not a relational database, so I'm just going to go through what it is. It's a real-time database. It's not like Hadoop. It's a real-time online transaction processing. Yeah, real-time database. Highly available database, highly scalable, and it's a wide column storage. And it's a disk-based database. Yeah? What Cassandra is not, well, it's not an ACID-compliant database, like our relational databases are. Yeah? It's not a relational database. So you create tables in Cassandra, but you don't relate the tables together. The reason being, it's a distributed database. And who's had to deal with sharding in a relational databases? Anyone? Yeah? So you say A to H lives on this database, and I to P lives on this database. You can't join the tables together across those databases, no? No. Okay. So Cassandra was designed to be ground up to be a distributed database, so it doesn't offer the relationships that the relational databases offer across tables. Cassandra has got something called CQL, Cassandra Query Language. It's a subset of SQL. It's not ANSI SQL compliant, as you haven't got joins and foreign constraints and so on. And it's not a document database. Yeah, like MongoDB, for example, Couchbase. So, how does it enable the connected world? Yeah. So there are three attributes around Cassandra. Its strength that it offers. And these are real-time. Cassandra is a real-time database. It's fast, okay? And it offers you always on. Your services are expected to be always on the internet. Yeah? My wife would be sitting in our living room, being unhappy about the decor, but she wants the services. She wants to be able to buy her shoes online all the time. Okay? And it needs to be scalable. Okay? She wouldn't be happy for a certain amount of time. The service worked, and then the service got popular, and it started becoming slow. She'll be frustrated by her shoes. Okay? So these three attributes is what I'm going to talk about today. So real time. So this is how I kind of see the kind of database world. To the right of the diagram, we've got Hadoop and Teradata. So these are what's called OLAP, offline analytical processing engines, right? In the middle, you've got RDBMS, and on the left-hand side, you've got Cassandra and HBase, and sort of NoSQL technologies. Now, the vertical axis represents the data volume, okay, so that they can handle. So Hadoop can handle massive volume of data, HBase and Cassandra can. RDBMS, not so much so. And then as you go to the right, the database technologies offer you more sort of flexible query mechanisms. Yeah, so Hadoop offers you kind of MapReduce, and it offers you very kind of insightful mechanism like exploring your data. And so does Teradata and various other OLAP engines. Somewhere in the middle is a relational database. They may offer you very decent amount of data, decent amount of throughput, and decent amount of query flexibility, okay? But it will never scale up to the level of scalability and throughput that Cassandra or HBase may offer. Okay, so with the Cassandra, we're talking about low latency, but offers you less flexibility in terms of the query patterns and the data modeling. Okay? So why is Cassandra so fast? Yeah, it's a real-time database. Its design is around its architecture. So on each server level, you do an insert of your data, okay? And it goes into two locations. it goes into commit log as a log structure writes, and it goes into mem table. And these are extremely fast operations in a machine. Okay? We're talking about, microseconds of latency in terms of write speed. Yeah, very, very fast. Cassandra writes go to commit log to make it durable. So your writes are safe. It goes into disk. It's very fast. It also goes into what's called mem table. Okay? Again, writes are fast into memory. And what it does is mem table sizes are limited. And as soon as you fill up the mem table, Cassandra will flush the mem table onto disk as a log structure writes, as immutable files. So once they get written to files, they don't change. So relational databases, when you update a column, when you update your rows, it goes to the disk location and updates the data. In Cassandra, it doesn't do that. You just get new versions of your data onto new files that it generates. And there's what's called a compaction process that runs in the background, which will merge the SS tables onto new SS tables. So say when you do updates of your data, the old versions will get deleted as part of the compaction process. So it just does the merging in the background. It runs this continuously in the background. Okay? So that's right. It's really fast. So let's talk about read. So reads, as I said, Cassandra is a disk-based database, yeah? So you're ultimately bound by the speed of your disk. But there are many ways in which Cassandra retrieves your data from disk as fast as possible. And this is the design that is adopted. So the reads will go through what's called Bloom filter. So Bloom filter is the way to select which SS table files to get to read your data. Okay? It will then look up the partition key cache. So in Cassandra, you have to have a primary key. So you have a key cache to look up where it might be on the disk, and partition summary in memory to look up where the summary of your key and where it might be on your disk, and there's an index around that, and then various components. So there is a mechanism in which Cassandra looks up your data very quickly as to where it might be on your disk, and then gets it from an offset of your files. Okay, so it's very much, again, read optimized as well from disk. And because the immutability of these SS tables, they don't change, they're highly cacheable by the operating system as well. So the OS actively caches the SS tables from the disk. So hot parts of your disks are in memory as well, which makes the reads very quick again. So, real-time database, yeah, very fast. So let's talk about always on. Okay? So you need to present your services out onto the internet, and you need to be always on. And Cassandra at the data tier will help you with that. So Cassandra naturally likes to replicate your data. Okay, so you create a cluster of servers in Cassandra. Okay? Each server may be a Linux box, x86 machine, and it has local disks. That's a typical configuration of a Cassandra machine. And as you do an insert into Cassandra cluster, it likes to replicate your data for you. Okay? It might replicate, say, as in this diagram, your data 3 times. What that means is you're going to have resiliency with your data. If one server dies, who cares? Yeah? You just replace that server. It will fix the data for you. Yeah? And then your service will continue to operate. Yeah? So it gives you that resiliency with your data. Many people are probably using multiple data center locations with enterprise systems. again, it's extremely simple to set this kind of configuration up with Cassandra. You had 2 lines in a configuration file to say the topology of your Cassandra clusters across multiple data centers. And as you insert data into a single data center, you set it up so that you create replications to the secondary data center. Okay? And you don't, as you insert the data, you don't really need to worry about its replication mechanism. You just do an insert. Okay? And then active replication strategy. Yeah. So you could be inserting against a single table in 2 data centers, yeah, and it will do bidirectional replication on a single table. Okay, which databases can do that? Yeah, it does this in a very elegant fashion, and you'll be surprised how easy this is with Cassandra. Okay. What that means is, if you lose your data center, yeah, things can happen. Hurricane Sandy, for example, that destroyed a few data centers in New York. Yeah, your service will continue to operate. And there was one company called Outbrain. They do a recommendation engine for websites, and they had Hurricane Sandy blow out their data center in New York, and their service downtime was 30 microseconds because they were using Cassandra in the back end. So they were able to carry out the service without having 0 downtime, essentially. So, okay? So what we call this disaster avoidance rather than disaster recovery. So if you're doing kind of SAN level replications of your database, for example, you might have a massive downtime when you're doing the recovery of your systems. With Cassandra, because you're replicating the data actively all the time per insert, you have virtually 0 downtime there. Okay. So scalability, another important aspect to your database. With the internet, you've got to be, if you're successful, hopefully using Cassandra, yeah, you're going to be providing a great service to your customers, and your customer base will grow, and they're going to be generating more and more data. Okay? With a relational database, you're going to struggle at some point. Yeah, you're going to struggle to keep up with the demand. So Cassandra provides you with a very scalable solution, and so I was kind of showing you Cassandra in ring formations. Yeah. It's not because Cassandra uses, do you remember token ring network? Who remembers token ring network? Yeah, okay. It's not because Cassandra uses token ring network. Okay, so this ring formation is just a simple logical representation of this hash range. So Cassandra requires you to provide inserts with a primary key. That primary key is hashed into a value, 128-bit value, okay, starting from 0 to the 2 to the power of 127 minus 1. And we put this token range into a ring formation. Now divide that range up by number of servers in a cluster, okay? When you hash the primary key value, it gets hashed into a value somewhere, okay? And it will belong in a token range. And you can quickly determine which server will have your data. Okay? This is deterministic. Every server can do this calculation. So you can speak to any of the servers in the cluster. It will do the same calculations, and it knows where to get the data from or where to send the data to. Okay? So, masterless design. There's no single point of failure. Okay? Every node is the same. What that means is it makes it horizontally scalable. Yeah? So Cassandra nodes talk to each other using gossip protocol, that we call it. Yeah? It constantly updates its metadata around the cluster setup. You add a new node to the cluster, it gossips about the new node, yeah, to the other nodes in the cluster, and then it rearranges itself automatically for you. So by adding more and more nodes, you just horizontally scale your cluster size. And what it can do is it can take more write throughput, yeah, more read throughput, and more volume of data. Okay. So so I've got like 14 nodes in this cluster. The biggest cluster that I know of is 1,600 servers in a single cluster across 2 data centers, yeah, handling petabytes of data. Okay. And just to show you kind of, have you heard of VLDB, Very Large Database website? They published a paper around comparisons of different database solutions and their scalability. And Cassandra consistently provided a very linear profile around the number of nodes against the throughput that it provided. Okay, so you have a very linear relationship. So it makes your growth very predictable. As you add more servers into your cluster, you're going to grow your throughput and your data volume in a linear fashion. Okay? Netflix. Okay, they did a lot of Cassandra testing. They're very vocal about what they do about their infrastructure. Who's heard of Chaos Monkey? Yeah? Yeah, they actively destroy their servers in production. Yeah, randomly. Okay, they take away machines randomly just to prove that their infrastructure is resilient. And they use Cassandra heavily, and they've done their testing. They've done, this is like back in 2011 that they've done this testing. Over 300 nodes, and providing million writes a second. Yeah? So makes Cassandra a very, very scalable solution for enterprises to adopt. Okay? So we talked about how Cassandra provides the real-time capabilities. Yeah? We talked about how Cassandra provides you with the always-on capabilities as well. Yeah, so disaster avoidance, how node failures or even rack failures and data center failures, it's tolerant because of this resilient model that it provides. And we've also talked about the scalability aspect of it, how Cassandra continues to scale. You can start off with one server, okay, up to thousands of servers across multiple data centers. Yeah. So let's just talk about use cases. Yeah. So I talked about Netflix, yeah, and they're one of the most vocal people about the adoption of Cassandra in their infrastructure. They use AWS for the deployment of their services. Yeah, who's heard of Netflix, by the way? Do you have Netflix in Poland, by the way? No. Okay. Unofficially, you have Netflix in Poland. All right. So they consume something like a third of the internet bandwidth in the US. Yeah, they provide the sort of video on demand service. You get Netflix client on any device you purchase, TVs, tablets, computers, and so on. You can watch movies on their platform. And they are heavy users of Cassandra. They've got something like 80 plus clusters in their production, 80 clusters of Cassandra, over 2,500 servers, yeah, doing 1 trillion transactions a day in their production infrastructure. Yeah, and that's a lot of transactions per day. And this guy came to give us a presentation at a DataStax meeting one day from Netflix. He said he's very pleased with Cassandra. And one of the things they had to do is their recommendation engine based on Cassandra. So when you log into these kind of services, they give you like, oh, so based on what you've been watching, we recommend you to watch certain movies, yeah? And they go, okay, you like watching My Little Pony. I don't like watching My Little Pony. My daughter has been watching My Little Pony. Yeah? Not my bag. So what they've had to do was to create a different user profile within a single household, okay, to give you different recommendations for different people in the household. And that kind of required 5 times the data volume. Yeah, to put out that simple functionality of providing the different profile recommendation engines, that required 5 times the data volume. They put this functionality out very quickly. They scale the database very quickly. They run on Amazon, so they can quickly provision servers. Great. But to scale the database out in that fashion, yeah, they've done this with Cassandra really quickly, okay? And House of Cards. Do you know the program House of Cards? Yeah? I've never watched it. But apparently they based the production of House of Cards based on the data they captured as to behavioral pattern of people watching different movies online, how they like to watch movies, what characters they like, what producers they liked. They based all of those kind of things on that data they captured on people's behaviors, used that to produce the program. Yeah, so the actors, yeah, the producer, and how they presented the adverts to people. Yeah, so if you're a female watcher, they used a different trailer featuring female character to the watchers of Netflix as an advert. If you're a fan of that producer, they produced did a producer-focused trailer to the audience. So again, Cassandra helped them with the capturing of enormous amount of data that people are generating by watching different movies. Play, fast forward, stop, skip, and so on. Another sort of, company that's using Cassandra, TurboTax or Intuit, yeah, they've got a product called TurboTax. It's an American system, yeah, so I don't use it, but it's an American system to submit your annual taxes, okay? I don't know why she's smiling, because I never smile when I'm submitting my tax forms, yeah? Do you? I don't know. It's, anyway, it's a system that allows you to submit your taxes. That's a lot of data, yeah? And they need to be resilient. So they've deployed Cassandra across multiple data centers and giving you the capability to submit your taxes in certain time of the year, a massive throughput of your data coming into the infrastructure, okay? Another big company using Cassandra to provide that capabilities. There's so many more use cases around Cassandra, okay? A huge amount of use cases, and I can't talk about all of them today, but if you're interested, it's worth going to planetcassandra.org, yeah? And then you can have a look at the list of companies and list of use cases and how they're implementing Cassandra in their production infrastructure. So, I may not have made my wife happy with this living room, but hopefully she's happy using the services that are in there. She can buy her shoes. And then, so DataStax, let me just talk about DataStax a little bit. So we're a commercial company behind Apache Cassandra project. We commit something like 80% of the source code into the community project, Apache project. We'd like the community to contribute a bit more, but we know about Cassandra. We provide enterprise-grade Cassandra, production certified, with added functionalities. Enhanced security, search integration, we're using Apache Solr, analytics integration using Hadoop, and going forward, Spark, Apache Spark, a very exciting project, and management capabilities. So that's it for today, and do we have time for questions and so on? Or cool. So thank you for coming. Dzień dobry. No, dziękuję bardzo. Yeah.